A bit of a stock as question that a student has asked for a little bit of help with. So, when molten potassium chloride is electrolyzed using another inert electrodes, chlorine gas is produced at one of the electrodes whilst potassium metal is produced at the other. What volume of chlorine will be produced? So, as we go to do this question, a really nice way to start out is probably just draw the setup. So, essentially, here's a beaker. In that beaker, we have two electrodes, and then they'll be joined. We'll have a power supply, and the long one's positive, the short one's negative, and then we've got the electrolyte itself, which contains K plus ions in liquid form, and then chloride ions also in liquid form as well. So it's hot. Yeah, so this thing here, hot, and it's around 1,000 degrees Celsius, plus minus a little bit. Hot, 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 hot. So, good way to get started is think about Faraday's laws. Now, I'm a big fan of formula triangles. Yeah? So there's three formula triangles that we're going to be using. One says the charge in coulombs comes from the current times by time. Yeah? Just remember here that this time is in seconds. The second formula triangle also has the charge in coulombs at the top. So we've got this thing, the charge in coulombs is equal to the number of moles of electrons times by Faraday's constant, which is found in the data book. And then our final formula triangle tells us that the number of moles of our substance X is going to be linked to the number of moles of electrons divided by the electrons per half equation. Yeah. All right. So there's our three. So the candidate here has done something really clever. They've underlined all the key information already, and that's a skill that's really worth practicing as we start doing questions. So another thing that's probably useful is to draw the correct half, is work out the correct half equation, which we can find in the data book. We're producing chlorine gas, so we've got chloride ions becoming chlorine gas. We go back to initial principles of Cohay's. We need to balance our key element. Put a 2 there, and then, well, there's no hydrogen, there's no oxygen, so then we just balance charge by putting in 2 electrons. In terms of the states for this is not going to be aqueous. Yeah, so this is actually liquid chloride ions producing elemental chlorine as a gas. So we're going to start this process by working out the charge. Coulombs is going to come from the current multiplied by the time. So we're told in the question that we've got 15.0 amps multiplied by 1.6 hours. So we need to times that by 60 to turn it to seconds, so to minutes, times it by 60 again. Major with calculators, that is going to be 86,400 coulombs. So we've now found out how many coulombs are in the system. Well, the next thing we want to do is we want to find how many moles of electrons were produced. So now we say our moles of electrons is going to come from the charge in coulombs divided by Faraday's constant, which is found in the data book. So that's going to be 86,400 divided by the values in the data book, 96,500, which gives us a marvellous decimal number. 0.895, blah, 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 which is still in the calculator. We can leave that there. So that's how many moles of electrons were pumped through the circuit. What we now want to do is work out the actual number of moles of the chlorine itself. And this is where we want to reference the half equation. So to work that out, it's going to be the moles of electrons divided by the electrons per half. Yep. And if we look up above, yep, we can see there's 2 electrons up there. So continue working down the page like big kids. Yep. We can now say, well, that is 0.895 blah 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 divided by 2, 0.4, I've got it written down, 447, leaving that number on the calculator, mole. There's a good time to actually go back and reread the question. So looking at the question, we're asked for what volume. Asked for what volume, yep. And these conditions here. So when we say these conditions here, yep, these lead us towards SLC. And in the data book, we're told that is 24.8 litres per mole. So, scrolling down here, we now know how many moles of chlorine. So we can now say that the volume of chlorine is going to be the number of moles multiplied by our molar volume. So 0.447 blah 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 times by 24.8. And that is going to give us an answer of 11.1 litres. At which point we should go back and check significant figures, 3 sig figs, 3 sig figs, 3 sig figs. We don't need to worry about this 25 degrees because the molar volume is given as 3 significant figures as well. All right, so that should be good.